Even with a comprehensive automated test suite, we can still get into situations where we need a debugger to figure out what's going on. Fortunately, Python includes a powerful debugger with the standard library, PDB. PDB is a command line debugger, and if you're familiar with tools like GDB, then you'll already have a good idea of how to use PDB. PDB is different from many debugging tools in that it's not really a separate program, but a module just like any other Python module. You can import PDB into any program and start the debugger using the setTrace function call. This function simply starts the debugger at whatever point you are at in the program's execution. For our first look at PDB, let's use a REPL and start the debugger with setTrace. You'll see that even after you execute setTrace, your prompt changes from the triple chevron to PDB in parentheses. This is how you know you're in the debugger. The first thing we'll do is simply see what commands are available in the debugger by typing help. This lists a few dozen commands, some of which you'll use in almost every debugging session, and some of which you may never use at all. You can get specific help on a command by typing help followed by the command name. For example, to see what continue does, type help continue. The curious parentheses in the command tell you that continue can be activated by typing C, CONT, or the full word continue. Knowing the shortcuts for common PDB commands can greatly increase your comfort and speed at debugging. Rather than simply list all of the commonly useful PDB commands, we're going to instead debug a simple function. Our function, isPalindrome, takes in an integer and determines if the digits of the integer are a palindrome or not. A palindrome, of course, is a sequence which is the same both forwards and backwards. The first thing we'll do is create a new file, palindrome.py, with this code. As you can see, our code has three main parts. The first is the digits function, which converts an integer into a list of digits. The second is the isPalindrome function, which first calls digits and then checks if the resulting list is a palindrome. The third part is a set of unit tests. We'll use these tests to drive the program. As you might expect, since this is a section on debugging, there's a bug in this code. We're going to first run the program and notice the bug, and then we'll see how to use PDB to find the bug. So let's simply run the program. We have three tests that we expect to run, and since this is a relatively simple program, we expect it to run very quickly. Instead of running quickly, we see that this program seems to run forever. And if you look at its memory usage, you'll also see that it grows in size the longer it runs. Clearly something is wrong, so let's use Ctrl-C to kill the program. We'll now use PDB to try to understand what's going on here. Since we don't know where our problem might lie, we don't know where to put a setTrace call, so we're going to instead start the program under the control of PDB using a command line invocation. Here we're using the -m argument, which tells Python to execute the specific module, in this case PDB, as a script. The remaining arguments are passed to that script. So here we're telling Python to execute the PDB module as a script, and we're passing the name of our broken file to it. What we're seeing is that we're immediately taken to a PDB prompt. The arrow pointing to import unit test is telling us that this is the next instruction that will be executed when we continue. But where is that instruction? Let's use the where command to find out. Where reports our current call stack, with the most recent frames at the bottom, and we can see that PDB has paused execution at the very first line of palindrome.py. This reinforces an important aspect of Python execution which we've discussed before. Everything is evaluated at runtime. In this case, we've paused execution right before an import statement. We can execute this import by running to the next statement using the next command. We see that this takes us to the def call for the digits function. When we execute another next, we move to the definition of the isPalindrome function. You may be wondering why the debugger didn't step into the body of digits. After all, isn't it evaluated at runtime like everything else? The answer is that the body of the function can only be evaluated when there are arguments supplied to it, so it will only be run when the function is called. The body of functions are checked for proper syntax when they're imported, but PDB doesn't let us debug that part of the process. We could continue using next to move through our program's execution, but since we don't know where the bug lies, this might not be a very useful technique. Instead, remember that the problem with our program is that it seemed to be running forever. This sounds a lot like an infinite loop. So rather than stepping through our code, we'll simply let it execute, and then we'll use Ctrl-C to break back into the debugger when we think it might be in that loop. After letting the program run for a few seconds, we press Ctrl-C, which halts the program and shows us that we're in the digits function of palindrome.py. If we want to see the source code at that line, we can use the PDB command list. We see that this is indeed inside a loop, which confirms our suspicion that an infinite loop might be involved. We can use the return command to try to run to the end of the current function. If this doesn't return, we'll have very strong evidence that this is an infinite loop. We let this run for a few seconds to confirm that we never exit the function, and then we press Ctrl+C. Once we get back to a PDB prompt, let's exit PDB with the quit command. Since we know the problem lies in digits, let's set an explicit breakpoint in there using the pdb.setTrace function mentioned earlier. Remember that the setTrace function will halt execution and enter the debugger. So now we can just execute our script without specifying the PDB module, and we see that we almost immediately go to a PDB prompt with execution halted at the beginning of our digits function. To verify that we know where we are, let's use where to see our call stack. Remember that the most recent frames are at the end of this listing. After a lot of unit test functions, we see that we are indeed in the digits function, and that it was called by isPalindrome just as we expected. What we want to do now is watch execution and see why we never exit the function's loop. Let's use next to move to the first line of the loop body. Now let's look at the value of some of our variables and try to decide what we expect to happen. We can examine values by using the print command. This looks correct. The digs list, which will contain the sequence of digits in the end, is empty, and x is what we passed in. We expect the divmod function to return 1, 2, 3, and 4, so let's try that. This looks correct. Divmod has clipped off the least significant digit from our number, and the next line puts that digit into our results list. If we look at digs, we'll see that it now contains mod. The next line will now update x so that we can continue clipping digits from it. We see that execution goes back up to the while loop as we expected. Let's look at x to make sure it has the right value. Wait a second. We expect x to hold the digits that aren't already in the results list. Instead, it contains only the digit in the results list. Clearly, we've made a mistake in updating x. If we look at our code, it quickly becomes apparent that we should have assigned div rather than mod to x. Let's exit PDB. Note that you may have to run quit a few times because of how PDB and unit test interact. After you're out of PDB, let's remove the setTrace call and modify digits to fix the problem we found. If we run our program now, we see that we're passing all tests and it runs very quickly. That's a basic PDB session, and it demonstrates some of the core features of PDB. PDB has many other commands and features, however, and the best way to learn them is to simply start using PDB and trying out the commands. This palindrome program can serve as a good example for learning most of the features of PDB.